Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss exercise 10.2 question number 11 to 14 of M.L.aggarwal class 9 mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel.
Let us solve the 11th question here, which is in the adjoining figure. Here BA is perpendicular to AC, DE is perpendicular to DF, and such that BA is equal to DE and BF is equal to CE, so that triangle ABC and triangle DEF are congruent. So simply we have to prove that in this question as ABC, triangle ABC here, ABC is congruent to triangle DEF. So here we can simply write it as, to prove this, as this is perpendicular means angle BAC is equal to angle EDF, as each is of 90 degree and they are perpendicular. Now here the given information to us is BA is equal to DE, means BA is equal to DE. This is the given part here. And the third information is given, BF is equal to EC. Simply we can write firstly BF is equal to EC, and as FC is common here, so we can write BF on adding FC both sides, here. In this part we will get plus FC equal to EC plus FC. On adding this part we will get as BC is equal to EF from here, and this is the given part. So now we can simply write here as, in the adjoining figure, triangle ABC from the rule of side angle, means here this is the hypotenuse, so RHS rule, sorry. So triangle ABC is congruent to triangle DEF, sorry, this is DEF, triangle ABC is congruent to DEF. So simply here we have this, by RHS rule of congruency we can prove this. So this is the final thing which we have to prove in this question. Here the 12th question is, ABCD is a rectangle and X and Y are points on side AB and BC of the rectangle respectively, such that AY is equal to BX. So prove that BY is equal to AX and angle BAY is equal to angle ABX. So here the solution of the 12th question is, we have to this structure we have ABCD is a rectangle and X and Y are points on AD here and on BC respectively, such that AY here and BX is equal to they are equal. So this is the given information to us, and we have to prove here BY is equal to AX and angle BAY is equal to ABX. Since ABCD is a square, we can simply say that the corners are of 90 degree, means angle DAB is and angle CBA. We can write it as 90 degree, and similarly we have XAB as 90 degree and YBA is 90 degree. Now we can simply write as BX is equal to AY. So this is the second part given to us. Now we have AB as common. So this is the common side here. So by RHS rule of congruency, we can simply say that triangle XAB is congruent to triangle YBA. Why RHS rule here? We can simply see that this is the hypotenuse, this is the side which is common in both the triangles, and this is the right angle which is common in both the triangles. Hence, we have used here the RHS rule. So this is the rule. Similarly, by proving this, we can simply say that here BY is equal to AX. in these both triangles, hence proved from here. Here the 13th first part is, in this figure given below, QX and RX are bisectors of angle PQR and PRQ respectively of triangle PQR. If XS is perpendicular to QR and XT is perpendicular to PQ, we have to prove that XTQ and XSQ are congruent triangles. And the second part is, we have to prove that PX bisects the angle P. So here the solution is, now the solution of this question here is, we have to prove firstly that triangle XTQ means XTQ and XSQ are congruent. Firstly we can take angle QTX and angle QSX because each are of 90 degree, so they are equal because this is the um, perpendicular. XT is perpendicular in PQ and XS is perpendicular to QR. Again, PQX is equal to XQS from here angle because QX is the bisector here. X is the line X are QX are bisectors of angle PQR here. So this is only from this we can write TQX is equal to angle SQX of triangle PQR. Now again we have QX as common in these both triangles, and hence from this by angle side rule of congruency we can prove that XTQ is congruent to triangle XSQ here. So these two angles are congruent here simply from that. Now the second part which we have to prove is, simply we have that xt is equal to because we have to prove that px here bisects, means px bisects the angle p here. So firstly we can simply write it as xt is equal to xs. Now in triangle xsr and triangle xzr we can simply write, because xt is equal to xz we have proved from cpct because this is congruent. Now in triangle XSR means in this triangle XSR and XZR, because these are also, this is also in 90 degree and this is also in 90 degree, so these angles are also equal. Now the angle SRX and XRZ are, because R is the bisector here means RX is the bisector, so we can say that these two angles are also equal. Now we have Rx here as common. So these three things we have written as common here. And again we can prove these two triangles here also by angle side rule of congruency as congruent. So by CPCT we can prove that XS is equal to XZ here, and here from this only, because XS is equal to XT and XZ is equal to XS. Simply we can say that XT is equal to XZ from this two information here. Means from this first one and from this second equation we can simply prove this part. So here we can simply write it as that triangle XTP and XZP are equal from this first and second part, and here XTP is equal to XZP which is equal to 90 degree, and here we have to prove that PX bisects the angle P. From this we can simply prove that PX bisects the angle here. This is the final thing which we have to prove here. Here the 13th second part is, in the figure given below, AB is parallel to DC and angle C is equal to angle D. Then we have to prove that AD is equal to BC and AC is equal to BD. So let's solve it. So firstly, to solve this question, we have constructed AE perpendicular to CD and BF perpendicular to CD, and then join A to C and then B to D. To prove the first part, here we have AD equal to BC, we have to prove, means AD is equal to BC. To prove this, we can firstly prove these two triangles AED and BFC as equal. To prove this, we can simply write that this is perpendicular, so angle AED and angle BFC is equal to each 90 degrees, so these two angles are equal. Now by construction, AE perpendicular to CD and BF perpendicular to CD. Now we have angle D equal to angle C because this is given here, and A, E and B, F are equal because distance between two parallel lines, these are two parallel lines AB and CD are equal. So here this is congruent by angle angle side congruency. So we can write here angle side congruency. Now we have to prove in the second part as AC is equal to BD. Means here AC is equal to BD we have to prove. So firstly we can write it as angle D is equal to angle C given, and DC is common here. So this is common. The third part which is written here, AD is equal to BC, from this thing which we have proved previously. And from these three we can simply evaluate that here it will be angle triangle ACD and triangle BCD are congruent by side here, side angle side congruency, because this is DC's side, AD is also a side, and angle D is the angle. So side angle side congruency we can prove this part, and from AC is equal to BD because by CPCT. 13th third part here is in the figure here, BA is parallel, means BA is parallel to DF and CA is parallel to EG, and BD is equal to EC, means BD is equal to EC, that is given. We have to prove that BG, means this BG is equal to DF, and BG is equal to DF, and EG, here this EG is equal to CF. So this we have to prove in this question. Prove this, firstly we can simply write as in triangle BEG and triangle DCF, we have angle B is equal to angle D. Here BEG and here this DCF triangle. The DCF we have angle B is equal to angle D because BA and DF are parallel. So corresponding angles are also parallel, also equal. And again we have angle E is equal to angle C because corresponding angles are equal, because CA and EEG are parallel. Now to here the given information to is BE is equal to BD plus BC, sorry here BC minus EC. So we can find out BE. So from here BC minus EC we can find out as BE. Now the second thing which we can find as BC minus BD also is equal to DC here. Means if we have to find the DC, we can simply subtract BC with EC. So we will find as BC with BD, so that we can find the value of DC. Now the final is BE is equal to DC from this part, and triangle, because B is equal to DC, so we can simply say that BEG is congruent to triangle CDF by angle side angle congruency. So here we have angle congruency, and now this BG is equal to DF from here. So this is CPCT because these triangles are congruent. So BG is equal to DF. Hence proved. Again the second part which we have to prove here, this is the first part, EG, means this EG is equal to FC. So again these two triangles are congruent, so we can simply say that EG is equal to CF by CPCT only. Now let us solve the 14th question, first part here. In this we have in triangle ABC and triangle CDE, BC is equal to, here this is given that BC is equal to CD and angle BAC is equal to angle CED, and from this is also given, and this is first part is also given. Now the third part is vertical opposite angle, means angle ACB is equal to angle DCE because they are vertical opposite angle here. Because of this they are equal. Now we can simply prove from here that triangle ABC are congruent to triangle DCE. by angle side theorem, congruency rule. We can prove this part, and from here only we can say that BC is equal to CD, which is given only. So simply we can put here BC is equal to CD as 3x minus 7 equal to 32. To find the value of x, from here we will get 3x as 32 plus 7. 32 plus 7 will be 39 divided by 3. From here we will get 13 as the answer here. Now we have to find the value of y. So 2y plus, from this congruency we can say that DE is equal to AB. Means here again from BC is equal to CD, we have just proved find the first part, which is the value of x. From DE is equal to AB, we can find the value of y, means 2y plus 3 is equal to 25. So 2y is equal to 25 minus 3 equal to 22 divided by 2. So it will be 11 as the answer here. So the value of y is equal to 11 and the value of x is equal to 13. So this is the answer of the 14 first part here. Let's solve the 14 second part. Here we have in triangle ABC and triangle AED. We have firstly AC is equal to AD, which is given to us in this question. So this is the given part. Now we have angle BAC is equal to angle DAE. This is also given here, and from here ACB, angle ACB is equal to angle ADE. This is also given to us in this diagram here, from diagram. And from these three given information we can say that by angle side angle rule of congruency, means because AC is equal to AD given, so angle side angle congruency, we can say that triangle ABC is congruent to triangle AED by ASA rule of congruency here. From here simply we can say that X is BC is equal to DE by CPCT, means BC is equal to DE by CPCT, and by putting the value here x is equal to 2y and x minus 2y is equal to 0, put it as the first equation. Now we have second part as AB is equal to AE by this congruency only. So AB is equal to AE, we can put it as 2x plus 4 equal to 3y plus 8, which will be 2x minus 3y and here 8 minus 4. So 2x minus 3y is equal to 4. From here put it as the second equation. Now we can solve these two equations. We will multiply this with 2. So it will be 2x minus 4y equal to 0 as the third equation, and 2x minus 3y equal to 4. So we will subtracting third and fourth equation from here. We can simply subtract this will be cancelled out, and here we will get minus x equal to 4. From here minus 4 and minus minus will be cancelled out, and y is equal to from 4 from here. So simply we can find the value of x as x is equal to 2 into 4, which will be 8 as the answer here. So this is the answer here in this question of 14 second part. Y is equal to 4 and x is equal to.
If you like this video, please like, share and subscribe my channel.